Physics students, good afternoon. Mr. Fugit here. Today in this video, we're going to be looking at a problem involving energy, specifically potential energy due to gravity. The question that we examine is going to be on your last homework assignment, number 8. This is question 14, which is the first of a 3-part question. We're going to be dealing with an object that is moving down a hill and how its energy changes at different points on the hill. So, I'll read our problem statement for us and we'll get going. So, our question says this. A 52 kilogram skier is at the top of the slope as in the figure. Okay? So in this problem, you are going to be given a figure. We have a skier coming down a hill. Okay? We're told that at the top of the hill, that is what the problem is referring to as point A, and at the bottom of the hill, that is what the problem is referring to as point B. So we're traveling, here's our, give us some context. Here's our object up here. We're starting at point A, and we're going to travel down the hill to point B. So it says at the initial point, point A, the skier is some distance, I'm given 17.7 meters, vertically above the final point. The acceleration of gravity is 9.81 meters per second squared. So we're told that we are some height above point B. So from A to B, we're told it's a height of 17.7 meters. Now the first part of this question, which is really the same style question all throughout 14, 15, and 16, says this. Find the difference in gravitational potential energy associated with the skier at points A and B if the zero level for gravitational potential energy is at point B. So this question is telling us that if our 0 point is down here, so we'll say that this is y equals 0, where we have no potential energy due to gravity. It's asking what's the difference in potential energy from A to B. Now, as you can guess, if the 0 point is down at point B, then the difference is really going to be whatever it is at point A. Because to find the difference, energy at point A minus point B, well, it's 0 at point B. So the question is really asking, what is the gravitational potential energy at point B? So here's what we would need to do. Well, we need to understand how to find potential energy due to gravity at point A. So, we have an equation, a relationship mathematically, where we can calculate the potential energy due to gravity, an object's height above some point. So, we need the mass of our object times g for the Earth times our y position at point A. Now, we know our y position is 17.7 meters. And I'm given a mass of my skier that was, let's see, I make sure I plug in my values correct, 52 kilograms. So I know my mass, I know my height above the reference point, and I know g for the Earth. So all I'm going to do is plug these values in. Potential energy due to gravity at point A is mass, 52 kilograms, times g for the Earth, 9.81 meters per second squared, times my height above this point, 17.7 meters. So I'll plug these values in, and we'll see what we come up with. 52 kilograms times 9.81 meters per second squared times 17.7 meters. I'm going to get a value of potential energy due to gravity, point A, of 9,029.1 joules. Now remember, the question was worded such that it wanted us to find the difference in gravitational potential energy between point A and point B. So to find that difference, I would just subtract what I had at point A minus the potential energy due to gravity at point B, which we were told that was 0, meaning our number isn't actually going to change. Potential energy due to gravity, the difference, what the question's saying, the delta value, which don't worry too much about that, just asking for the difference in potential energy due to gravity at those points. So 9,029.1 joules. That's how we would go about approaching this specific problem. At this point, point A, all of our energy is potential, and as you can guess, as we start to move down the hill, some of that energy is going to be transferred to another form, namely kinetic energy. Now, the next two questions that follow up question 14 are asking for find the difference in potential energy if the 0 level is at point A. So it's really asking us the reverse. If our 0 level was up at point A, we would call this y equals 0. Our potential energy at this point is 0. Okay? So it's saying that if our 0 point was up at point A, what's the difference in potential energy from A to B? Which again, we have the same object, we're moving the same distance, meaning our number is really not going to change at all. It's just a value of difference between those 2 points. Okay, so the way we would approach the follow-up question to this part, what would be part 15, isn't going to change at all. And then lastly, we're told to find the difference in potential energy if the 0 level is midway down the slope. Okay? So we're told, lastly, if this is our 0 point, or y equals 0, our potential energy due to gravity here is 0. It's really asking us for what's the difference from one point to the other. Okay? Difference between points, from A to B. Okay? And again, our difference really isn't going to change, because regardless of where we define that 0 point, the mathematical calculation is all going to remain the same. Our object remains the same, its mass, G remains the same, and the difference between our points is, again, going to remain the same. Okay? So regardless of where we define that 0 point, the difference in potential energy there isn't going to change. The only way our potential energy here would change is if our object itself begins to move, or if somehow we were to gain or to lose mass. Okay? But those things aren't happening in this scenario. Okay? So really, 14, 15, and 16 are kind of asking us the same things, and just worded in a slightly different way. And it's geared to help us see that regardless of where we define our 0 point, the difference in potential energy between points A and B will always remain the same. So hopefully that gets us kind of a good direction for where to go for these problems, how we approach this idea of potential energy or stored energy due to gravity. Good luck.